to be talking about the real number system and how to classify rational numbers. So the first thing we want to talk about is what is the real number system and what are rational and irrational numbers. So the real number system contains all numbers that really exist. So at this point, probably all the numbers that you're familiar with. Eventually, we'll get to numbers that are outside the real number system, like imaginary numbers, but we're going to focus just on the real number system today. So in the real number system, we have two types of numbers. We have numbers that are rational, and numbers that are rational would be everything contained down here in these circles. So we want to be looking at this grouping down here. And then we have other numbers that are irrational. So a number can either fit into the irrational circle or the rational circle. And once we put a number into the rational circle, we can even get more specific, but all of the names that we can give it are going to kind of work their way into like an inner circle. So a couple things we need to know. Rational numbers are numbers that can be written as a fraction. Irrational numbers cannot be written as a fraction. So what we want to look at is within the rational numbers, we can get more specific. So obviously there's a lot of numbers that can be written in fraction form, fractions, decimals, if they terminate or repeat, they can be written as fractions. We can write whole numbers as fractions. We can write positive numbers and negative numbers. So any number that you can think of that can be turned into a fraction would be in that blue circle, rational. Now, some numbers are in the blue circle, but they're also in some of the other groupings. So for example, the number -3. -3 is a rational number because we can write -3 as a fraction. We would just say -3 over 1. But -3 also is what we would call an integer. An integer is a positive or negative whole number. Now, we can get even more specific. There's lots of numbers that are integers because 5 is also an integer, right? It's a positive number, but we can be even more specific and we can call 5 a whole number. Now, 5 would technically be a whole number, an integer, and a rational number. And then we can get even more specific and we can talk about natural numbers. Now, the only difference between whole numbers and natural numbers is that natural numbers are what we naturally use to count. So think back to when you were 3, 4 years old and you were learning how to count, maybe 2 years old. When you are naturally learning how to count, you start with the number 1. 1, 2, 3, right? These are numbers that we can actually see, we can touch, we can feel, they have quantity. Whereas the idea of nothing, 0, it's a little bit more abstract. It's harder for us to naturally understand. So our natural numbers are often referred to as our counting numbers. So a natural number is also a whole number, is also an integer, and is also a rational number. So we're going to take some time to just look at some numbers, and we're going to think about what categories they fit into. We want to be as specific as possible, but we also want to list every category that they fit into. So the first thing we're going to look at is the square root of 12. Now, 12 is not a perfect square. So its square root would be this really long, yucky decimal. And because 12 is not a perfect square, it is what we would call an irrational number. And the reason is, it's not a perfect square. Now let's take a look at -0.25 repeated. Now repeating decimals can actually be turned into fractions. And there's a whole algebraic process for doing that we can eventually learn. But 0.25 repeated would be actually the same thing as 25 over 99. And then it would be negative. So because that can be turned into a fraction, we would say that that is a rational number. Now, it doesn't fit into any other categories because it's not a whole number. All right, the square root of 9. The square root of 9 is 3. And if it has the negative symbol, that means we're talking about the number negative 3. So negative 3, we can now get a little bit more specific and we can move inside not just the rational circle, but to the integer circle. So the square root of 9 is negative 3, and that would be an integer and a rational number. 72 over 4. We can simplify 72 over 4. We can divide both of those by 4. And that would give us 18 over 1. And so 18 over 1 is now a whole number, an integer, it's rational, and it's a natural number. So it fits into all 4 categories. And then finally, pi. Pi is a relationship that describes circles. And pi is an irrational number that goes on forever. It has a decimal value, but it doesn't repeat, it doesn't terminate, so that's what we would consider irrational. So that's a little bit of a look at the real number system.